All right, good morning, class. Believe you are staying safe. You're having a nice time wherever you are at home. We miss you and we hope to have you back on campus soon. All right, today we'll be looking at introduction to programming. And before now, I dropped an instruction in our Edmodo platform. You were instructed to download the basic interpreter, either your mobile version or your desktop version. Please do well to do so because after this introduction class, we go into basic proper. Now, at the end of this class, you're expected to be able to understand what computer programming is, define the following terms, the syntax, grammar, semantics, state the various types of programming languages, and various examples of programming languages. Now, what is a program? It's a question that every one of us should be able to answer when you hear the word program. You say a program is a set of instructions. There are rules that is written in a language of a computer. Just like our everyday life, we have our various languages, like we have Hausa, we have Benin, we have Ijaw, we have Yoruba, we have Igbo. Likewise, that's the same way computer have various languages like Java, Pascal, Basic, and so on and so forth. So a program are a set of instructions that are written in a computer language. And the most important thing, what program does is that it instructs the computer system on what to do. The computer cannot act by itself. Just like a body without a spirit cannot act or cannot move or cannot be useful. And so likewise, a computer system without the software component of a computer system, which is the program, the computer itself cannot make decisions on its own. So a program is used to instruct the computer to perform a particular task. There are certain attributes of a good computer program. Number one, the program must be correct. And when we say correct, it simply means that when you build a program that will add two numbers, it should add two numbers and not to subtract two numbers. In other words, the purpose of its creation must be fulfilled. The number two, that a program must be clear. When we say must be clear, simply means that the logic should be easily understood by any other person. Man, I can write a program and Mr. B is being asked to troubleshoot that program, in order to make the program more, maybe to diagnose an error. So if the logic is not clear or not easily understood, then it becomes difficult for other persons to do. Take for example, our generators, our equipments were developed um, by foreigners, but our people could study this machine and they have a good understanding of it. Then they can able to repair when such machine goes bad. So it's simply also bringing that to a program. So if the logic behind a programming code is not easily understood, then it becomes difficult for someone to alter the code or to make or to maybe to improve on that code. Then number three again is that basically we build programs in modules. So the modules should but however, after building programs in modules, we try to connect those modules to interact to work as a system. Basically, when we say computer system, for example, now you built the speaker, you have the keyboard, we have the monitor, we have the system unit. All those things are various modules or various parts of the computer system. They also can classify as a module. But at the end, they try to interconnect those components to work as a single unit. That's the same way, that's where it is when it comes to a program. We can build a program of a calculator One module will be for addition, other module will be for subtraction, other module will be for multiplication, one for division, one for square root, one for sines and cosine. Then at the end, all these modules will be bring together to build an interacting system. So, but if the modules are not properly broken down into subroutine that can interact in a clear way, it becomes difficult for them to interact. So we should be able to build a module that can be easily be connected to interact as well. Most importantly, this program should be easy to modify. For example, for example, before now, the pass mark for NUC was 40. So if you have 40, you have an E. But after so many years, NUC tried to remove the 40 and make the pass mark 45. In other words, there is no longer E, but now have only D. Now, if you have built your program with the former grading system, that doesn't mean you should discard the program for the new grading system. All you need to do is just try to adjust the grading system within your system, and by so doing, the program should be able to run on the new system. But assuming it's not easy to modify, then that cannot be achieved. That simply means that that program is rendered useless. That means it has to be another new program. So having said that, so let's consider, well, what then is a programming language? We said earlier that programs are instructions written in a computer language. Now, what indeed? So when we say computer language, we mean programming languages. So what exactly do we mean by programming languages? So basically, we can say there are rules for instructing computer to perform a task. We have said that for most times, there are also notational systems for describing computation in machine readable and human readable form. When we say describing computation in machine readable and human readable form, basically, um, and if your woman doesn't understand Nembe language or doesn't understand English language, for example. So, but sometimes you need an interpreter or a translator that will help you to communicate that language between the Nembe person and the English person. In other words, so when we are trying to use notational system for transcribing computation, we are trying to make it um, in human readable form, but with the aid of a language translator, it can also be transcribed to machine readable form. The reason why there is a need for us to place those two languages together, both machine readable and machine readable, is because if we are to code in machine language, it's become difficult. We saw in class how computers can store 5. That means 00000101. Come on. So that means if you want to now write a long sentence, you can imagine what it means. If a computer to store 65 in ASCII code means, A means 65 in ASCII code. We have to convert it to binary. Then come on, that becomes difficult. But at the same time, because of the notional system that we have been able to achieve this goal, both human readable form and machine readable form. Just like normal languages uses a syntax, uses grammars, parts of speech, semantics. When we say syntax, about the pronunciation. So normal languages have these 4 structures. Likewise, programming languages also use this certain thing. We also have syntax, we also have grammar, we also have semantics. Semantics has to do with the meaning. The grammar has to do with well-formed structure, such as blocks of statements. Then the syntax has to do with the structure. Please note this. The main difference between syntax and semantics is that syntax has to do with the structure of the program, while semantics has to do with the meaning of the programming language. Now, if we just go into syntax and semantics defined properly, so say the syntax of a language is the grammatical rules that governs the way in which words, symbols, expression, and statements may be formed and combined. That is true. But we need to know that basically it has to do with the structure of the program when it comes to the syntax. So when we are considering syntax, our basic aim is the structure. Is we have when we have to make a decision. We have to maybe is either yes or no. Okay, where to transfer command. When do we transfer command to the left or to the right, or either the yes command or the right command? All depends. Is all these things are being made and being achievable with the aid of the syntax of the language. But when it comes to the semantics, this has to do with the meaning of the term. For example, now we saw in class that 2 plus 3 times 4. When we solve it from the front side, we had 20. And when we did it from the back side, we had 14. Now the question is, what do we intend to achieve? That is where semantics have to come in. Are we expecting to have 20 or we're expecting to have 14? So we can't tell. So there must be a defined meaning of what we expect a program to do at a particular time. That is why we have to look at natural language and formal languages. Now that brings us to what we call the natural language and the formal languages. Now the language we use every day so that our English language are called natural languages. There's no issue with those languages, but there is a problem. Any language written in natural language often suffer ambiguity. When we say ambiguity, we mean that it has more than one meaning. For example, now look at this expression. Calculate 4 and 6 divided by 2. Could simply mean add 4 to 6, then divide the answer by 2, or divide 6 by 2 and add the result to 4. That could be that. Or it could mean divide 4 by 2 and get one result, and then divide 6 by 2, get another result, and so on. Now you could see that we are facing ambiguity because we're having more than one meaning to this particular expression that was written in natural language. And that was why we have to consider formal languages. Formal languages differ from natural language in that they have precise semantics, which means they have a precise meaning. As we said earlier, that semantics has to do with the meaning. So formal languages have a precise meaning. And so every programming language must be written in formal language and not natural languages. So the instructions written in formal languages usually have only one meaning. By so doing, there will be no place for ambiguity or having more than two meanings for a particular expression written in natural language. So if that is the case, so we will stop there for today, for now, and we continue in our next slide on types of programming languages. So in our next class, we'll be considering various types of programming languages we have. I will kind of consider the classes of programming languages we have. So you should be able to know when to use a particular language or not. So based on the task at hand, what you intend to achieve, so that will guide us on a particular language we intend to use at a particular time or not. So I believe you are able to have a clear understanding of what a programming language is and what is syntax, semantics, the grammar. We also looked at formal languages at the same time. We also talk about natural languages. So in our next class, we will continue. Thank you for listening.